This is my Wurth Elektronik FeatherWing sensor road test. So this is the Wurth sensor module. It has a humidity sensor which has the little slots around it, presumably to allow humidity better access to the chip. It has a temperature sensor. The humidity sensor has a temperature sensor in it as well. It has a separate temperature sensor. It has a 3-axis accelerometer. And it also has a barometric pressure sensor, absolute pressure sensor, which also has a temperature sensor in it in case you need to calibrate the pressure, which is often dependent on temperature. So this is a FeatherWing compatible module. Has the pins already on it. It's a stackable connector with the sockets on the top and the pins on the bottom, and they supplied a Feather M0 MCU. I just had to solder on the headers, which allow it to stack right on top of the FeatherWing sensor module like this. So what could be simpler? It's just plug and play. And this has a USB port to connect up to a computer and program it. Now I also purchased a display, a FeatherWing display, and it also has a FeatherWing compatible socket on the back, so I can plug this whole stack onto the display. Like that. So now we have a complete computer which has the MCU, a series of sensors, and a display. And of course we need a box to put it all in. So I 3D printed a case. Here's where the display goes. Inside here we have a pocket for the battery. And over on this side there's a pocket for a switch to turn the power on. And then there's a port for charging through a USB cable. So I've made up a lithium polymer battery, wrapped it up in capped on tape, and put a switch on it, and a plug-in connector, a JST connector, which plugs into the Feather MCU at the top here. So, and then of course there's a lid that just snaps on to the top of the case to keep everything in place. And the way this is designed is that the whole stack just slides in on these little rails that are printed into the device. But first we probably want to put the battery in, and it is a nice snug fit into its compartment here. So there's the battery in the case, and the switch goes over in this pocket. Let me just put it through here for now. Get the wires out of the way, and we'll slide this in. This is a tight fit, so there's a very tight fit actually. And it's snug on all sides, so it's not coming out. There's a little brace on the bottom to prevent the cards from coming out of their sockets. And I'll just put it all the way in. There we go. And I can plug this power cable into the JST socket up here. Now let's just see if it turns on. I believe the battery's charged up. There we go. And you can see it's Wurth sensors, and the pressure, this is showing the barometric pressure. And then I've computed an altitude based on the pressure. So I'm in the basement and it's showing minus 302 inches from my baseline. And I can change the baseline, but I wanted to get a very accurate measure of the altitude, so I put it in inches. And if I raise it up, the altitude changes quite easily. It changes about every 3 inches or so, which is very astonishing, actually, that it can measure the pressure difference in just 3 inches of air. The next up is the X accelerometer, then the Y accelerometer, and the Z accelerometer. Now I've recomputed from these accelerometers the angle with respect to gravity. So instead of actually showing acceleration, I'm showing an angle. And you can see here that the Y is showing minus 47, 48 degrees because I've got it at this angle. If I put it vertical, you can see that it goes to minus 90 degrees. Next up is the temperature. Now there are 3 temperature sensors in here, but I'm only displaying the separate one, the more accurate one. And then the last one is the relative humidity in percent. So it's 30% humidity down here. So that's the software and the hardware. That's how it's built. I'll just snap this on and we can start measuring some angles and see if that works. I'm going to turn it off. There, it works fine. Okay, I'm going to see if I can snap this lid in. It's also very tight, so it goes on here. I may need, I may need a little screwdriver to help me along. Not the right type. Okay, that is on there nice and tight. And I'm going to seat the switch in there later. It fits. I've already tested that, but I need to make sure that I can access the USB port at the same time. But let's measure some angles. So starts up really nicely, battery operated. So I'm going to take my road test stand and see what angle it's sitting at. So it's at 61 degrees, and I believe I set it to 60 degrees when I was building it. I'm not sure it's exactly on straight here in terms of the puck that it's mounted on. One really simple test is to put it flat on the table to see what the angle of the table is, and the Z-axis says that it's vertical, so it's 90 degrees. The Y-axis is saying it's minus 0.69 degrees. The X-axis is about minus 0.9 degrees. So if I put it this way, the X-axis should be about 90 degrees. It's only reading 80, and that is a bit of an offset in the X direction. I've noticed that it goes more than 1 G in the other direction and less than 1 G in this direction, so that needs to be calibrated a bit. but basically it's measuring angles quite high resolution. So here we go, X is minus 90 in this direction. Okay, I have another stand here. Let's try this little stand. I'm not exactly sure what angle I set that to, but it's saying it's 40 degrees, and that's about right. Let's get that reflection out. So this is a nice little package. I made it very rectangular just so that I could use these flat surfaces to measure angles easily. Now, one of the little enhancements that I could do is to make the display rotate to so that I can read it vertically, or so that I can read it when it's upside down like this. Then I can just flip the display over. Because I have the accelerometer that tells me what the angle of the device is, so I could easily use that to program which way the display is actually showing up. So this is a pretty nice little package, I must say. It's I was expecting that the brick shape would be really ugly, but now that I'm holding it, I actually like it. It's really square, and that's exactly what we were trying for. So let me put this switch in here and we will see how we get along with that. Okay, the switch is now installed and ready to go. Of course, it's recessed so it doesn't interfere with the flat surface, and I can turn it on with a little screwdriver. And we're back in business. So now it's good to take outdoors and start measuring some elevations.